Hey everybody, welcome to our program today, Room Heat Pumps 2.0, cooling and heating in a small package. I'm Joe Wachunas here as always with my teammate Brian Stewart. And this webinar, like all of our series this year, is brought to you by Electrify Now. It's an all-volunteer organization promoting electrification as the quickest path to decarbonization and something that we can all take an active part in achieving. And it's brought to you by the Learn program. It's a San Diego-based workforce education and training program that's partnered with us at Electrify Now to offer these free energy efficiency and electrification webinars. Check out their amazing website and resources at www.sandiegololearn.com. And all year we've been talking about the benefits of electric homes and transportation for homeowners. These include lower energy bills, cleaner indoor air, of course, less pollution outside, more comfort, and increased safety. So lots of great benefits. And today we're talking about an exciting technology that we've visited before, but that it's changing quickly, room heat pumps. So we're going to give you some updates with some of the biggest experts in the field. Brian, set the stage for us today.
Yeah, thanks, Joe. So yeah, this is always a popular topic, and it's always one that we're enjoy digging into because, like Joe said, it's changing quickly, and there's some very interesting developments that we're going to get into today. But in general, a room heat pump, you'll hear them called different things, but I think that the industry is kind of settling on this terminology of a room heat pump, which means that it's in general a DIY installed self-contained product that is meant to heat and cool an individual room, or in some cases these things are powerful enough. You've got a small apartment or something like that it could really take care of one room, and the adjacent rooms will get some benefit from that. It requires, all these devices require ventilation through a window. So the whole idea of these is that they're meant to be able to provide heating and cooling without the need to kind of do a really heavy installation, which is what we typically talk about with even ductless heat pumps, are much more complicated to install. All right, so that's generally what you hear in terms of a definition for those. We're going to go through the kinds of options that are available on the market today and a little glimpse of what's coming. But we in the past have been talking about the available models that are now kind of, or at least we're referring to them as mild climate room heat pumps. And these, and we'll go through kind of the models and things that are available and what these look like. But this is what you've heard us talk about in the past. These systems don't have an active defrost system. So that means that they're really only capable of heating down to about 40 degrees or so, because otherwise they're going to get in a situation where the heat pump is, frost covered and it doesn't have that defrost capability. So these things provide really great cooling. In fact, they're generally kind of inclined towards cooling, and they're as good an air conditioner probably as you're going to find. But they have this benefit of also offering supplemental heat, but only above 40 degrees when outside temperatures above 40 degrees. The exciting thing is that there's this new category of room heat pumps that we're referring to as all climate room heat pumps that do have active defrost. And these are being engineered because of the early kind of developments. We're really going after a super efficient cold climate type heat pump that can heat to 5 degrees and below. Some of these go down to as much as minus 13 degrees with really high capacity heating. And of course, they provide great air conditioning as well. These are the new products on the block that we're excited to talk about today. And then we're hearing about, and we'll talk a little bit about this with our panelists, the third sort of category, which is kind of in between, more capable than the mild climate. So they're capable of heating below freezing temperatures because they've got active defrost, but not quite as capable as these super cold climate models. And this middle product is really interesting because I think for a lot of climates, that's going to be the sweet spot, and hopefully a little bit less expensive than the all climate ones, et cetera. So we'll talk a little bit more about that, but at the moment, there isn't a product to buy in that category. All right, so we'll start with the mild climate. If you've been with us before, this will be a little bit of a review, although there's some new developments on the product side here as well. But generally speaking, these devices come in 3 kinds of configurations. They're usually marketed as an air conditioner with supplemental heat. So if you're out there looking for one, that's terminology you might want to use or keep in mind when you're searching. but they come in window mounted, saddle mounted, and portable versions. They typically run between $500 and $800. They're really good air conditioners, and they provide decent heating, which we'll talk about, with some limitations, and also great dehumidification. The thing about these things, if you are using them for heat, is they're twice as efficient than electric resistance heating, and so that's great because you're going to use less energy for heating, but also it means that it's providing way more heat output than a space heater, typically something like 3 times the heating capacity that a typical space heater would provide. They run on a standard 120-volt plug, and as we said, they do not work when outside temperatures fall below 40 degrees. And because of all those limitations, these currently are not going to qualify for federal tax credits. There are some local incentives that have been put in place to get these into homes, in many cases to prioritizing the cooling benefits, but they're not going to qualify for any federal tax credits. Okay, so the window mounted units basically look like a window air conditioner. It is essentially a window air conditioner that is able to operate both directions for heating and cooling. So it sits entirely inside the window, and of course there's limitations because of that. It has to be a vertical sliding window, and in general these things need to be screwed to the frame, because what you don't want is to open the window and then have the unit fall out. Some of them need some external supports as well. That varies from model to model. The window is not going to be operable, so once you put this in, you can't open the window. It's going to block the view to some degree. And you can see, because it's sitting inside the window, depending on how big your window is, there's a large gap that needs to be sealed. And this is just like a reality of window mounted systems in general, but they all have their idiosyncrasies in terms of how well they can be sealed. And these window mounted units have a large sealing area, which means that you should expect there's going to be, air coming in and going out through the seal, even if you do a pretty good job. They come in 120 and 240 volt models. So this is something you really need to pay attention to if you're shopping for one, because if you buy the 240 volt model, unless you've got a 240 volt plug, like a dryer type plug nearby, it isn't going to work. So that's really important to make sure you're getting 120 volt model. You need to have a plug nearby, etc. And some of these come with electric resistance heaters as backup heat. You want to avoid that if you're interested in heat pump mode, because you're going to get less heat from it in terms of the output. You can tell because they'll give you a BTUs per hour rating, and if it says 3,500 BTUs per hour, that pretty much means it's an electric resistance model. Okay, then there are a few saddle mounted versions which are really interesting. These have some real advantages because they straddle the external wall. You can see that the window now is much more closed, which means that there's a lot smaller ceiling area. The window remains operable, which is great, and doesn't block the view, which is also good. They're a lot quieter because the condenser, you can see in this picture on the right, is outside your house essentially. So the noisiest part of the device is outside your house. And there are some wall thickness limitations though that you need to be aware of, and so check the specs to make sure it'll fit with your particular situation. And then there's portables, and in this case the whole device is inside your house, and so in some cases they're the easiest to install because you don't have to really fiddle with getting it through the window and all that kind of stuff. They have window kits that work with vertical and horizontal windows, so they're a little bit more flexible that way. They have a large ceiling area again required, which is going to mean you're going to get some leaks, air leaks. That's just a reality. There's no permanent fixtures, which is nice, and that's one of the reasons why these are oftentimes the best for renters, because some buildings won't allow you to put window mounted units in. They come in single and dual hose models. We really highly recommend the dual hose models. In fact, you'll see in a minute, we really only recommend the dual hose versions because the single ones are going to create a pressure differential where they're basically blowing air out in one place, and that means that air is getting sucked into your house somewhere else, which negates some of the efficiency. And then these things create condensate when you're heating. So Some of them have little onboard tanks, but we really don't like that. That's pretty fiddly. We really like these ones that have onboard drain pumps, so you can basically put a little hose that goes outside your window, and so you don't have to worry about emptying condensate tank. All right, so the key features to keep in mind, as we mentioned, make sure you're getting 120 volt version. You got to have a plug nearby the window. Avoid these electric resistance ones. You know, if you are okay with electric resistance heat, you might as well just get an air conditioner and get a separate space heater, probably be cheaper. Look for these Energy Star ratings or these high SEER ratings. 12 plus means that you're going to get good efficiency. Check the noise, because they're all different in terms of noise. You know, the more quiet ones are 45 dBA or lower in their kind of low setting. And then, as we mentioned, we really recommend you get a dual hose and a drain pump version if you're interested in a portable model. So we'll provide this, and I think we put a link in the chat to our handout that has this information in it. But these are the models that I am aware of that are on the market today here in the US that you could purchase. Many of them are available through Amazon, for example, or other online distributors. You know, places like Home Depot and Lowe's will have them as well. You can see here for the window mounted ones, Midea has two really good models. It's kind of hard to argue with them in terms of, if you look at the specs here, they're the quietest, they've got the highest efficiency, they're Energy Star rated, they're the lower cost options. So those are probably the best performing models out there. Frigidaire's got a decent one, but you can see it's less efficient, it's more expensive, and it's louder. So, you know, I'm not sure why you would go there. And then the Friedrich model looks really nice and pretty interesting, but it's way more expensive. So, and I'm not quite sure what you're getting for the money, to be honest, but it looks like a really capable product as well. There's really only one supplier that's providing these saddle mounted versions. It's Solius. There are saddle mounted air conditioners, but these are the only models that I'm aware of that also have supplemental heat. They have pretty good efficiency. As you can see, they're quieter, again, because they're saddle mounted, and the noisy part, the business end, is outside your house. These look really good. You can see they're a little bit more expensive than the window mounted ones, but pretty attractive. And then the portable ones, there's really only three that I would recommend. These are the ones: the Midea Duo, the Cooper Hunter, and the Winter, because these are the only ones that have both the dual hose and a onboard drain pump. So again, here, if you just look at the specs, the Midea kind of stands out a little bit in terms of slightly higher specs and a little bit quieter than the other two. But yeah, those are the ones that we would recommend. This is kind of the landscape for what's available in this category. All right, let's switch to the new kids on the block. This is kind of really exciting, because these are very capable products that don't have a lot of the same limitations that we just talked about with the mild climate ones. There's three that are available today that we're aware of. There's Gradient, which has what's called the all-weather window heat pump. Midea calls it a packaged window heat pump, and then Gree has this window style version that's like an air conditioner with that they call the ultra heat model. These are way more expensive, but it's because they have capabilities that the others don't. They're in the $3,000 to $4,000 range. A lot of these are just coming out now, so we'll see what the price, kind of how it settles. But these things are incredibly capable. The Gradient and Midea package systems talk about being able to provide really high capacity heat down to -13 degrees. So this is like a very efficient heat pump, very similar to what you would see with a ductless system in terms of its spec. Super high efficiency with coefficients of performance, even at low temperatures of 1.8, which is pretty amazing. They run off 120 volt standard plugs, 15 amps. They're just becoming available. We'll talk about their go-to-market strategies with our panelists in a minute. They're kind of working through that now. And these things do qualify for the 25C IRA tax credits, 30% of the upfront cost up to $2,000. So, you know, we'll see, of course, how those tax credits, whether they survive, but at the moment, these products are efficient enough that they qualify for those credits, which is pretty spectacular. Few things to keep in mind. They're heavy. They're bigger than the other devices that we looked at. These are in the more 110 to 140 pound range. So really needs 2 people to install them. Some of the manufacturers, and we'll get into this, actually recommend a professional installer. Some of them are, you know, really set up to be DIY installed. They need a fairly large vertical sliding window in order to fit them through. So it needs to be at least 27 or in some cases 29 inches wide. The Gradient and Medea models both come with these really cool, we'll talk more about this with our panel. It's this onboard atomizer that disperses condensate, which is great. It means you don't have something outside dripping. If you're in a high rise, that means it's not like dripping down on people walking by on the street, etc. Very cool feature. And then it's one of the things I'm really excited about with the Gradient model is it offers this MERV 13. It's an extra purchase, but for, you know, like $60 or something like that, you can get a MERV 13 air filter, which is also really cool. I wish there were more systems like this that offered good air filtration if you're in a wildfire area. This can be really helpful. Most models just offer a kind of simple mesh screen. They'll keep the dust out, but isn't going to clean your air in any significant way. The Medea and the Gradient model both have a really slick installation. This is a video from Gradient, which kind of shows how the install process works. You know, I mean, of course, it'd probably take you a little bit longer than this video to do it, but you can see that there's a window kit that you build and then stick it on your window that's going to support the device. Then they both have this kind of hinging mechanism that allows you to pick up the product, again, with 2 people, and slide it through the window in this kind of opened configuration like this. And then it sets onto the structure that you put there and then tips down. And then you put the window sealing components in and close your window and you're good to go. You can see there, I think it's also exciting to see that all these manufacturers have really paid attention to the looks of these products. They're a lot better looking than most of the window heat pumps that you see. Okay, so this is the specs for the Medea and the Gradient models. They're very similar in terms of what they deliver. Super high efficiency, really great. And a lot of the same features in terms of this onboard atomizer, etc. They're both quite quiet in their low modes. So a lot to really love about this product. Both these products, and we'll talk more about the experience that we've seen with installations of these with our panelists in just a minute. There's less information available on the GREE unit. This is, again, more like a conventional air conditioner, but it's again, super efficient. They say that it'll heat down to -8 degrees. It's a little bit noisier than the other units, again, mostly because it's a window-mounted product. So yeah, a lot to like about this one as well. Okay, so those are the products that are available. We're going to introduce our guest panelists now and talk about what some of the real world feedback from installing both types of these products in the market. We have 2 amazing panelists with us today. We've got Christopher Diamond from Northwest Energy Efficiency Alliance, which we refer to as NEA here. He's a senior product manager there and co-founder of the Advanced Heat Pump Coalition. He focuses on variable speed heat pump technologies for space heating and cooling. So he's done a lot of work with room heat pumps, but also with ductless and ducted systems. He's got a master's degree in building systems engineering and over 25 years of experience in this zone of energy efficiency, solar engineering, and solar energy technologies and heat pumps. So he's got a wealth of knowledge. And then Sean Armstrong, he's the managing principal for Redwood Energy. Any of you who are electrification geeks will have heard of Redwood Energy. They're a leading efficiency and building electrification organization in this country. And Sean is also become one of the leading efficiency and electrification experts in North America because of his work in this area. There's some really good information on their website if you're interested in this, including their pocket guide to all electric retrofits. He's done a lot of work on how to electrify homes without doing panel upgrades, et cetera. So wealth of knowledge here, as well as a lot of work on installations of these room heat pumps. So welcome to you both, Sean and Christopher. Thank you for joining us today. I'm going to stop sharing.
Yeah, thanks, Brian. And I need to just share with you all that NIA is not in any way endorsing the Electrify Now objectives. We're a fuel agnostic organization, a nonprofit focused on bringing and remove new products to market, removing their market barriers. And we're really interested in this kind of general classification of which originally called micro heat pumps. It's a broad kind of area. There's a lot of cool stuff happening, and I've been involved with bringing this in for about 6 years now. So happy to entertain questions.
Yeah.
I want to add to that. I just want to say that I work in affordable housing, right, which is owned largely by very wealthy people. If you guys understand, like it's deed restricted for low-income households. That doesn't say that the people who own it are low income. So I try to bring forward strategies that are just talking green, money. I'm very much interested in how to save money in the process of electrifying, which I think is the least expensive way to upgrade homes and maintain homes is through electrification. And so I'm just here as well to have a nonpartisan, fact-based conversation, just like I've always wanted to. But of course, now is a good time to just make it really clear that this is about saving money, and it helps out wealthy people and poor people.
Absolutely. I mean, I think that's one of the, thanks for that, Sean. I mean, one of the things that's really exciting about this whole classification of product is that, it's going to be a game changer, particularly these all climate versions for people living in apartment buildings, et cetera. And so that gets you into like all sorts of, economic brackets. And we're really interested in being able to electrify older apartment buildings, et cetera. So that's one of the reasons why these products are really, really interesting. But maybe just to start us out, I think both of you have had some really interesting experiences working with the testing of these products, both kinds, the sort of mild climate and the all climate versions. And so I'd really like to maybe just start with, and Sean, maybe you could start just giving us give us a rundown of the experience that you've had with both of these types of products, and then we'll get into like what you've learned from it. But I first just paint the picture with kind of what you've been involved in terms of testing.
We've been testing portable heat pumps, the ones that you roll up to the window, since about 2017. And I've tested in my own home. And it's like, we're not as much of a building science field testing organization as Christopher Diamond gets to work with. So I just want to defer to greater expertise. But nonetheless, my college engineering students, we bought 4 of them and we tested them during the same winter. And we got to see some of them, for instance, do go down to 20 degrees, but they don't advertise it. And they don't explain that they're doing a defrost cycle, but you can hear it. And so I've just seen that, like, the products that roll up to the window. Sorry, giving a webinar. No. Thanks. Sorry about that. Okay, so the products that roll up to the window are okay. But one of them that you were pointing out, the Idea Duo, when I had that installed at my staff person's house, she was nursing her new baby, and it was like 10 people in East LA. And the air conditioner was both life-saving and the baby could sleep next to it because it was quiet enough. So it's like, okay, that gave me confidence that this was something that we should and could invest in. And I wrote the cold climate 120 volt heat pump specification from about 2017 to 2019 with the state of New York, which then turned into what we're seeing here, the Gradient, which won that contest. And so I've been involved in a lot of the design. And I want to defer to Christopher, who's done a lot of personally knows these products, but we did install about 115 or 130, I think, of the Gradients, but the first generation, when we learned lots of lessons that they then incorporated. And I haven't got the touch of Idea yet. I just saw it at the Orlando conference. So that's my quick background on that.
Great. Yeah, Christopher, why don't you answer the same question? Because I know you've done a lot of testing on these kind of things, and you've been involved in the New York program as well, I believe so.
Right. So there's sort of testing in the lab, and there's testing in the field, and I'm engaged in both of them. I want to give a head nod, though, to the New York Public Housing Authority and NYSERDA. They were the ones that kind of kicked this off by issuing a challenge and an offer to purchase tens of thousands of these and put them into New York public housing. And so that competition resulted in both Midea and Gradient, building products for a market that had been kind of ignored, right? We've had room air conditioners that can reverse cycle for decades. We've had room air conditioners for decades. No one's built a room heat pump that has the capabilities of like a ductless mini split. And so that kind of kicked it off. I've done some field testing with the portables, the reverse cycle variety, and Gradient's first generation. And, you know, really learned that everybody's pretty familiar with multiple heating systems, but how it's used is really important to get a lot of energy savings out of it. Just putting it in the window is not enough. You actually have to make sure that the settings are so that it's displacing heat, right? Because if you have a competing heat source in your house, an electric baseboard or some other heat source, it could swamp the savings you're getting from. It could kind of not leave enough work for the room heat pump to do. So you want to make sure you've set the heating, set the thermostat setting, for example, to be in heating mode and to have its thermostat setting just a little bit higher than your backup or your other heating source. Otherwise, the two will be competing. So that's a pretty important learning right there.
Yeah.
All of them seem to add some benefit, but these new generation of saddlebag design was a clear improvement over energy savings, customer experience. I think we're talking about a whole new category of product, and that's exciting. Seeing that then proliferate to maybe a little wider range of moderate climate as well as the cold climate, I think that's going to happen in the next year or two. So NYSERD has been doing some field testing. NIA has been doing field testing. The Electric Power Research Institute has been doing some testing. Now California MTA, kind of a sister organization, is also doing some field testing as well as a couple of utilities. I think we'll start to see utilities being engaged in supporting these products through consumer education, possibly incentives. It's a little hard to say what that will happen and when, but there's now a test procedure, there's an Energy Star rating, there's a tax credit criteria, and the second generation of products, which is really the Midea and the Gradient and the GREE, I look to be phenomenal.
Christopher, you said, you know, it's a clear improvement. Is that all because of the saddlebag shape that enables this vast improvement?
Well, the technology is definitely better, but something about the way customers were interacting with them meant that they clearly were being used more for heating, whereas the little portables and the room and the window air conditioner variety, I think people still thought of those as just little air conditioner enhancers. They didn't think of them as full-blown space heating cooling systems, which is really what they are. They're fully capable cold climate mini splits put into a package that's really different from what we've experienced in the past.
Yeah, yeah. Well, I think it's telling that this first generation, you know, the mild climate ones are advertised as air conditioners with supplemental heat. You know, it seems clear that the driver for purchase typically is cooling, and then it's like heating feels like a bonus. You know, I feel like we've been trying to like make it more understood that these things are quite capable heaters, in, you know, with you know, guardrails around the conditions where they'll work. But I think it feels like the market still thinks of them as air conditioners in general, but it feels like these new devices are really set to change that.
Yeah,
There
so
was
one
a
piece.
question over. There's a question over in the comments that I wanted to speak to, and also
yeah.
wasn't yet on the slides, which is the Energy Commission has just put out a grant application, GFO, that we applied for. And I was working with EFOCA. You know, you're familiar with their wall-mounted, almost like what we're talking about, but it has two little ducts through the wall. Anyway, about repackaging that as a portable roll-up that could use a slider window but be a cold climate heat pump. And so someone was asking, like, is there a product yet for sliders? And that's coming up, perhaps. Maybe we'll win that grant application, but eFocus says they're going to come out with it regardless. The grant just accelerates things. So fingers crossed. And then one other thing to mention on this question of sliders, what to do about the ones that go back and forth instead of up and down. If you have a back and forth window, horizontal slider, and you put in one of these heat pumps because it can fit, you can find online windows that are sliders themselves that you put in to that gap so that you can continue to have a window there, and you just have to put it into that gap and then slide it up to fit. And of course, get a gasket that's decent around it. But it is a retrofit strategy of putting in a lot of these different ones that ask for up and down windows, and you're like, what do I do with the slider? That's what you buy an online window.
So it's a kind of a hack, Sean, that folks can do. But I guess, have either of you heard, are the manufacturers thinking of sliders in future
Yes.
products? Okay.
Oh, I learned that from Vince over at Gradient when I was talking with him, and I was complaining about this. Like, well, look at this. We're trying to figure out, should we supply this with our product or just give them links and tell them how to do it? And I was like, yeah, brilliant. You just taught me something. Thanks. They make dog adapters. Someone just put in the text there for slider windows. Yeah, I think that we just have to look a little bit more deeply into the retrofit products that are out there to support this, because there do seem to be some strategies that other people have thought up.
Yeah. Well, let's start with let's dive into the kind of the use case, the best use case kind of conversation a little bit for these two different products. Let's start with the mild climate ones. I mean, from your guys' experience with these, how do you describe what is like a good candidate? What would be a good candidate for one of the mild climate devices? What kind of home?
Well, I mean, if California counts as mild on the coastal part, then I would say my business partner, he put in one of the ones that, well, he has a very well insulated house. He has thermal curtains, etc. It's a 1,500 square foot house, and he heated his entire house with a portable heat pump. And it wasn't even the Midea Duo. It was I think the Winter. And that's because his house has literally a brick of thermal mass behind his couch. He's done everything possible as an engineer to make his place work. And that was being met with just one window heat pump. So super efficient 2-bedroom house, or apartments, or as you've said before, a room, maybe 2 rooms. Depends on the efficiency and the efficiency of the house. And apartments are more efficient because they share so many walls. So I think they benefit apartments more than most homeowners realize.
Yeah, and I'd say that, there's a comment in there that's spot on, is that if you have a space that's currently heated with electric resistance heating, even just getting one of these older mild climate units, it's going to cut the amount of electricity needed to heat the space in half to maybe 1/3. And these cold climate ones would do it to a quarter. They were really like a COP of 4 in that temperature range. But even just, a lot of California, a lot of mild climate, if you have electric resistance, it's not a bad choice. It's not you still need to have your backup heat during the colder hours.
Yeah. I mean, I think it's, it's easy to forget, how much of the year is in that 40 to 60 or 70 degree temperature, even in California, which is a pretty sun, we think of it as a pretty sunny place. There's depending on where you live, there's a huge portion of the year that's in those temperatures, which is kind of the ideal window for those mild climate units.
Well, okay, but here's a crazy one. Nate the House Whisperer over in Ohio?
Yeah.
He's also a house flipper. He loves to buy beaten down houses and then fix them up, but he usually lives in them for a year or two. So he bought a house in Ohio that he insulated well, did all the spray foam and such, and then in Ohio kept it warm with 2 of those straightforward DIY roll-up heat pumps. I really learned about it from him quite a number of years ago. And so that can be done in a well-insulated house if you don't mind doing some electric resistance in the wintertime, is to use those most of the year in a well-insulated house, even in a kind of difficult climate.
John, your definition of well-insulated is well above the typical contractor.
Hey, man, there's 213 people here, and I know that some of them have a well-insulated house.
That's true.
Yeah. All right, so let's let's talk about use case then for these all climate versions. I mean, I think it might be interesting just to hear a little bit more about the NYSERDA project, that kicked a lot of this stuff off in the first place, because there was a very specific use case that they had in mind when they put the spec out for these products. Isn't that correct?
I'm sorry, what was the question? What was that? What was correct?
The use case for the all climate versions, and a lot of these products that we see today were the kind of the result of a kind of RFP that came. I think you mentioned it from New York.
Yeah,
maybe you could talk
that
a bit
went
more
from
about that.
Multiple meetings at ACEEE events with folks who were there and asking them of like what was the potential and the possibility of heat pumps and going through refrigerants and everything, and that then translated into NYSERDA saying yes and writing the specifications, and which really meant I wrote the first draft, they wrote a second draft, I wrote a third draft, they wrote the fourth draft, and that was the one that went out, which is beautiful as a whole bunch of scientists trying to figure out what's the right thing. So, and that, IFOCA competed, but decided they weren't the right product. And it was also New York structured it as a recoverable loan. They weren't giving a grant. And so you had to be, as a business, like kind of desperate to give them a recoverable loan. And because most of these things are like, here's cash, have a good day. So anyway, that restricted some of the participation, but absolutely there was Gradient and Idea, and Gradient specifically that came out the gate first with a they did Gen 1 and then Gen 2. That's a quick story.
Like what was the problem they were trying to solve? I mean, let's start there. I want to get back to the use case thing. Like why did they do this?
Oh, because New York is lots of stash windows. Like all the mansions around Central Park, all of them already have crappy little air conditioners in them. You can't believe the value of this house, and they're blocking the view, but they're desperate for air conditioning. And just seeing how the window air conditioner market was saturated in New York with really low quality products, and that they weren't giving the opportunity to do heat pump work with that, which was clearly available, in 2016, 17, 18, cold climate heat pumps were going strong by then. So,
Sean,
the conversation, please.
Yeah, I'll add one more thing about the NYCHA need was that they have a lot of, a couple 100,000 multifamily building units. A lot of these have old oil boilers down in the basements that are reaching end of life. And so they have to replace the radiators and a whole bunch of stuff. The amount of cost to have a union plumber come in and do all that work really meant that they had enough money to buy a heat pump and put it in there and this is key, if it could be simply installed and meet the whole heating load, not just like displacement of what's needed, but the whole. That's why the spec was pretty aggressive. It was a cold climate, got to meet the whole home load for New York City. So that has a design temperature of 24, 21 degrees, something like that. Cold.
And Christopher, ductless heat pumps, we get that we're getting this in the chat. Ductless heat pumps would be more difficult to install. So it seems like these make sense as a use case in apartment buildings, especially. But if you're in a single family home and you're weighing a ductless heat pump and a room heat pump, and they're maybe similar costs, what are the advantages of room heat pumps? Why would a person choose?
How about cost? What we're talking about is reducing the cost from $6,000 a ton, which is 12,000 BTUs an hour, down to $2,000 or $1,000 or $500 a ton. It's a reduction of 2/3 or more in cost. That's the reason. And I just want to point out, tons of single-family homes have room air conditioners. They might as well have a room heat pump, and it'll get a much better air conditioner out of it. Pardon me if that was not my turn, but that's the elephant in the room. This is so much less expensive if we can go this route of using the window and doing it yourself or with minimal support than it is for buying it through a mechanical contractor who's going to charge 25 to 40% markup just as the markup, as well as labor. And it's more or less triples the cost, sometimes quadruples in big cities. The cost of the system. So if you just buy the system and do it yourself, you're miles ahead.
You can imagine too, and like let's think back to Christopher's comment about these multifamily buildings in a place like New York, where you're talking about like 20 or 30 or 40 story buildings, so putting a heat pump outside, where you need an outside condenser mounted in that situation would be, that's difficult, whereas these things that can be installed from inside the building, it's a game changer in terms of the lower cost of installation.
They were so desperate for this solution, so desperate, that I saw them taking out radiators and then cutting a hole in the wall of the building and then building a box outside so they could put a ductless mini split there to be able to heat and cool the room in this like little new enclosure they'd made in the wall. That's how financially stressful it is to try to fix the whole huge boiler system as opposed to take it out and put in a cold climate heat pump, because they were doing that kind of stuff before we came to this solution. Use the window in a thoughtful way.
Yeah, the other use case that Rachel points out is where you don't have any ductwork, existing ductwork. Your other option is a ductless mini split, and having, one in each room is extraordinarily expensive. Having a couple of room heat pumps might be a better alternative for that house that had hydronic or some other kind of non-ducted solution. There is another kind of countervailing thing, where the use case is not appropriate. And the ones that we're seeing in our field study is a lot of window sills aren't high enough off the floor. So there's sort of physical space constraints of like, is there a bush directly outside that window or a tree? Is there enough vertical height from the floor to the window sill? Is the window wide enough? These are things that are, not kind of like immediately obvious when you're like shopping at Home Depot and you see one of these things in an end cap. You're not going to know how wide. You're not going to remember, was my window 26 inches wide or 27?
Yeah.
That reason is why I'm very hopeful about our roll up to the window type of heat pump that we're working on with Efoca, because you often don't have access to the space outside, or the windowsill itself is not in a good situation, as you're pointing out, and something that has a more compact interaction with the window, so you don't have to open it as wide. I think that's the main advantage of the portable heat pumps, is that they do have more flexibility of what windows they can work with.
More form factors may be needed. But okay, so you guys are selling the cold climate.
Efoca,
really?
For the question there, Mary, you want to know, it's EPHOCA.
We'll put
Efoca.
a check. I was just getting the link up. I'll put that.
There you go. Sorry. Continue on.
No. But so maybe let's talk about availability. We've been talking about these cold climate heat pumps for a little while. Are they available for folks? How can people get a hold of them? Where are they going to be sold? What do we know so far?
Well, go ahead. I think Radiant is selling through their website.
Yeah, so I had we've had some good conversations with Medea and Gradient this last couple of weeks about this, and I think it's fair to say that, and you guys jump in if based on what you're hearing, but from what we're hearing, they're developing their go-to-market strategies now. I would say that it's still in development, but in general, what we're hearing is Gradient is kind of prioritizing their direct to consumer, direct to building owner kind of approach. So you can literally go online or go onto their website and send an email to them and say, I want one, and then you can work with them that way. And Medea seems to be more prioritizing their the HVAC contractor and distributor network. In fact, we're hearing from them that, at least to start with, that they're kind of discouraging the DIY thing a little bit. It sounds like they're more going down the road of having their HVAC contractors offer this as a service. So, for example, I was talking to the Gensco distributor here, and what they're imagining is that this is one more tool in the toolkit for their HVAC contractors who are assessing the best solutions for one of their customers, and this is something they can offer. And I asked him, well, do you think it's possible that someone could buy one of these from an HVAC contractor and pick it up and install it themselves? He didn't rule that out, but I think, they're generally kind of tracking more towards their contractors installing them. So we'll see, because this is still a little bit fluid, I'd say, but that's the difference we're seeing between the two brands at the moment. Are you guys hearing anything different, Sean and Christopher?
Well, I'll just say that, we haven't reached large scale production of these things. You know, if you get to large scale production, costs will come down and the distribution channels will widen. Right now, they are focusing on what they can get in kind of limited runs through, like in the case of Gradient, I believe it's B2B kind of sales, or, you know, that's sufficient quantity that's worth their time and effort. For Midea, I believe they're going to use more conventional distribution channels, sort of two-step HVAC distributors and contractors. I don't know where GRE is going to be at, to be honest, but this is still not yet at scale.
Yeah.
So don't anticipate, don't assume it's not going to like radically improve over the next 3 years.
Well,
Scott,
I
what do you know about the
got
green
pricing.
pumps?
I got pricing from Gradient just last week from Peter there. And the pricing basically, like the difference between buying 200 of them versus 10. And I think they wanted to do like a 10 order as their smallest. They're definitely targeting apartment complexes, which is smart, wise.
Yeah.
It's what it's for. You know, it's original design. And I think the difference cost is like $200 each increment from like it's $200 more if you go, or should I say, I think the top costs like $3,500 a piece and the bottom cost is like $3,100 a piece. So you're just in that range of like in the low 3,000s. That's what they charge per heat pump.
John, what do you know about GRE? I think you have some familiar with the GRE products, don't you?
I only saw it and I haven't gotten to play with it at all. So I don't want to say I know much about it. You know, I contacted them because I have been chasing that product for years myself, right? And they offered me a price. I could buy it for $2,000. I could get one shipped to me, and but I didn't have $2,000 at that moment. I could do now, so maybe I should grab one. But it was just like, you know, wintertime, just at Christmas. So the it looked pretty good in Orlando. I went up and I kicked it around and such, and looked like nice and metal and solid, and had appropriate handles on it. And but Christopher, I think you should speak to it.
Before Christopher, Sean, did you ever think of giving one of your kids a GRE heat pump for Christmas that year? Maybe like the two birds with
Absolutely. I have. And I really appreciate their dehumidification function. I live in a temperate rainforest, so I'll put that out there that yes, I have one for my kids' room, and it does work as a dehumidifier as well, and I appreciate that.
Nice.
Yeah.
Sorry, over to you, Christopher.
Yeah, I mean, you know, both these, or maybe all three of these initial cold climate window heat pumps are cold climate capable. They're really a category of top performance kind of machines. I've installed both the Gradient and the Midea. They're pretty straightforward. I would say the first time you do it, it's, you know, maybe a 1 hour activity. And then after that, you could get it down to 20 minutes. You're probably going to spend more time explaining to the occupant how to use it than it takes to actually install it. One of the things that I really appreciate that was in the NYCHA NYSERDA spec is that this ability to atomize the condensate and melt water is really a big deal. I mean, it's the technology. Otherwise, it's just a pretty simple heat pump, you know, or an air conditioner that goes in backwards. But being able to take that melt water, because during the winter, when the ice builds up on the outside, because it's super cold coil out there, you got to melt it, and you got all this water, and you don't want that cold water running down the outside of your building onto sidewalks. So being able to turn it into a fog, and then the dry, cold air is just going to suck up that moisture, and it's not. We've done the two manufacturers that I've worked with a fair bit on this, that they've clearly tested the ability for that moisture to be dissipated quickly and easily. So I think that's the real distinguishing difference between kind of a moderate or a mild climate and these is, what do you do with the condensate water? What do you do with the melt water? So condensate is that dehumidification that Sean talked about, and melt water is from the defrost cycle. Both of them you don't want to just like leave inside the building shell.
Yep. Yeah, I noticed the GRE has an onboard little tank that you have to empty. So yeah, I think that water management thing is like a pretty big deal. So those atomizers are very, very sweet addition to the product features. Yeah.
The other thing that I want everybody to be aware of is that if you don't have good ventilation inside your house, these are not going to solve that. They don't come with ventilation. They're like a ductless mini split. They do heating and cooling. They don't do ventilation. The Apaca has a model that has ventilation incorporated. Some of the PTACs, PTHPs have ventilation incorporated. You don't need a whole lot of ventilation in a space, but if that's important, we have yet to see those products be integrated into these window heat pumps.
A question from the chat, just talking a little bit about the window gaps in the mechanisms for sealing, where the window's closing around the heat pump. Sean, I know we were talking ahead of time that you've seen some even improvement in these various iterations of these cold climate heat pumps. Do you want to talk a little bit about that?
Sure. So our Gen 1s we put in, and they had insufficient gaskets. They just weren't, I mean, according to people, they weren't keeping insects out, or they weren't keeping water out when it rained, or weren't keeping sound out because they lived next to the trains. These are all low-income households that we recruited. They overall had very strong, like, yes, thumbs up, we like the product. That was true. But their main complaint was around the windows. And Gen 2 came out with a terrific gasketed product that seems to work much better. I don't have enough experience with it yet to say, like, for sure. But it certainly was responsive to all of the things that people said about the first generation gasket. So those are the things I think that people want to keep out. Sound, well, smoke, potentially during smoke season. And right now, to expand for a moment, this is a problem when you have the sleeve for a through-wall air conditioner, because there's a fair amount of not gasketed material, and you can like lose like 40% of the air through that sleeve. It can be pretty dramatic sometimes. So this is a long-standing problem, and to reinforce what Chris was saying, I mean, one of the big moves forward is this effort to atomize the water. To give credit where it's due, that was EFOCA, because it's the word epic in Italian, EFOCA. But I am from Wisconsin, so I say EFOCA because that's my roots, yo. So anyway, EFOCA, they're the ones who were looking into atomizing back in like 2018 when I was talking with them, because there was quite a collaboration. I was talking with Daikin, I was talking with NYSERDA, they were talking to each other, blah, blah, blah. So as we had this like group effort to try to figure out a retrofit strategy, I want to say they're the ones who are like, this is something we should do. And they continue to try to innovate with it. But so far, they haven't actually pulled it off. So hats off to Gradient and Idea for succeeding and getting an atomizer, successfully built in.
Great points. Yeah, Christopher, anything to add to the gasket question? Do you see improvements? Was that in any of your field studies you've seen?
I mean, it's always the Achilles heel of any of these through the wall, through windows, air sealing around that is left to kind of the installer to get right. And there's probably adequate foam and all that provided in these kits. It's the diligence of doing it well that really what it comes down to. There was a question earlier I want to kind of address, which is, do you get a mild climate or a cold climate? And it really depends a little bit on if you're doing a full displacement or just partial displacement. If this is going to be your heating, your primary heating, pretty much in any climate, you want to get the cold climate one outside of truly warm climates. There is going to be a midpoint product out in the next year, possibly two, which is the moderate climate, because there are three different levels of three different temperature regimes, essentially, that I see coming into the market. These cold climate ones that'll work down to the -10 kind of degree Fahrenheit. The mild climate that stops at about 40 degrees. And then there'll be another one that's sort of a 17 degree Fahrenheit range product. And I think that's real intriguing because that opens up a whole different kind of price point, potentially a little bit smaller, a little bit less capacity, but needing 9,000 BTUs in a single room is quite a bit of heating and cooling.
Yeah. I mean, I think it's one of the things that it's important to keep in mind, because you don't get the complete picture when you just talk about the minimum operating temperature. Like, let's talk about the mild climate ones, for example. They'll work down to 40 degrees. They're not very efficient at 40 degrees. They're pretty efficient when you're in the 60 degree range, but the colder it gets, the less efficient they are, and the less heat you're going to get out of it also typically. And that's true of any heat pump, but these cold climate ones, you know, even if you're operating at 40, if you're operating the cold climate one at 40 degrees and the mild climate one at 40 degrees, you're going to see two really different things. You're going to see a lot of heat coming out of the cold climate one at very high efficiencies, and you're going to get a little bit of heat coming out of the mild climate one at lower efficiency. So, you know, you're going to save money from an operating standpoint with a cold climate heat pump, even if it's a little bit overkill for your climate situation.
And comfort, but
sorry.
No, sorry, continue.
But that it is one of the always things to keep in mind, you know, but I do feel like what you're talking about, Christopher, these middle products are really interesting because it feels like that's a whole, you know, you're going to get pretty efficient heating down to 17 degrees for a lot of people. That's going to be all you need. And that's
right. They won't be
exciting.
They won't be full displacement, but they will be substantial displacement. Yeah. And remember, the cold climate spec was written really for the New York Housing Authority, which was like, we need 100% displacement. Full stop.
And I want to put out there this air conditioning part of it. So you know how heat pumps and their inverters, they operate in a certain band. And you can make the band go towards the colder direction, but it does somewhat starve on the air conditioning side. And in heat wave climates in Arizona, like if the Arizona Housing Authority had written the same cold climate, or not the same, they would have written a different one. They'd say, yes, it gets to below freezing here. We absolutely need this to work in the 20s. But we also get to up to 122 right now, and we think we're going to get up to 125, 127 in coming years. So we need the inverter part of it to also succeed in discharging heat and doing the air conditioning work in the summertime. And we've run into that problem already in California, where we have to have a coastal sizing and say it's a 10,000 BTU AFOCA heat pump. And it has to be a 15,000 BTU AFOCA heat pump in the inner part of California, where it gets to 115 now and 117. Otherwise, it doesn't perform air conditioning. So I think this, like, cold climates are not ideal for highly hot climates. And a mid version of that might be where you get into the 20s successfully and you get up to the 120s successfully.
You know, you bring up something really interesting, Sean, is that these cold climate ones really are all climate. They are really large heat exchangers. They have not only really good at the low temperatures, but they've got enough heat exchanger size that they can get rid of heat when it's 120.
They could, but they have to be programmed. So
look at this,
I'm working with these. Yeah,
I was surprised that, you know, the specs from the mild climate ones and the cold climate ones, they basically all say, they all put like 110 degrees. Some of them go to 115 as their high end temperature where they'll operate within. Now they might operate higher than that, but that's what they talk about as the kind of window of operation, outside temperature, 110 or 115 degrees. So pretty consistent amongst all the models. There's one question here about durability and maintenance. It's one of the things we haven't really talked about. Do we know anything about, you know, do these last as long as a ductless system? Do they need maintenance the way a ductless system or a ducted system might need? What do you know about that?
They're not built as well. I mean, the cold climate ones that are the window ones, yes. I'm talking about our existing do-it-yourself roll-ups, the ones that are window ACs. Those are like, they're just not as high quality, say, getting a Fujitsu ductless mini split in terms of all the components with them and the likelihood that's going to last 5 years doing a good job or something like that. At least that's my opinion. But you've seen window ACs can last. I've seen them last 40 years.
Yeah.
I've had to replace 40-year-old window AC, so they're reasonably durable. I'm not saying they're.
Go ahead. So there's sort of this. The good aspect is that they're all factory sealed. They doesn't require a contractor to install refrigerant or do a seal or anything like that. So they're hermetically sealed. They should last a long time. These ones that are the saddlebag design, I think they're essentially ductless mini splits. So I would expect the same lifespan that we see from ductless mini splits. That's a 15-year conventional measure life for these things.
That's good to hear. There's a quick question. I know we're coming up on time. What about locking your windows? A simple thing like, if you have that, it doesn't go all the way down. Are people gonna be able to lock their windows? What about security?
Yeah,
Yeah, we heard that concern. You can install new window locks, drill a hole in the wood and put a little lock there. There's things you can do to lock your window in the new height that it's in.
Okay, so there's workarounds for the window locks. Great. Brian, do you want to, any last questions?
Well, there's a question about, this one is a good one for you, Sean, since you're the kind of like watt diet person. How would these things compare to a ductless mini split in terms of the how much power it's drawing from your panel?
They are designed to be less power intensive than a ductless mini split. Most ductless mini splits are 12,000 BTUs and above, and and they take compensatorily more wattage. These at 12,000 BTUs, 10 to 15,000 BTUs. They are designed to run usually in 1,400 watts of power, as opposed to say 2,000 watts to 3,000 watts of power, and they can plug into essentially any outlet in your house. That's their design is that a 15 amp circuit that you might have from pre-1962 or a 20 amp circuit from 19 go on, that they should be able to accommodate both those circuits with their power demands. But maybe one of you guys knows the specs better than I, but that's the design. The intent is that they'd be able to fit onto existing 120 amp circuits that you have for your plug loads.
Yeah, these new saddlebags will draw something on the order of 1,100 to 1,400 watts at their peak, which means if you've got it on a 15 amp circuit, which is not uncommon, not a 20, but a 15, if you do something like a blow dryer, a toaster, a microwave on that same circuit, it will trip the breaker.
Yeah.
If
So you
it's
don't put it on
something
a
like,
kitchen circuit.
no,
Not,
yeah,
I mean,
and
not a kitchen circuit, not a bathroom circuit.
but conventional little table lamps and a computer, anything short of like one of those gaming computers that have like 2 horsepower worth of electricity being drawn for them, you're okay.
And all right, maybe to close, what are your thoughts for this market over the next year plus? We've been seeing them come to market. Do you think, are we going to hit an inflection point where these are more readily available, or do we think we still got some work to do?
I think if you want them now, you can get them. There's just a little bit narrower distribution channel, and as we go to scale, it'll keep growing. I don't think that, especially if you're a B2B and you're doing a multi-family kind of development, both are available.
What does B2B mean?
Business to business, sorry.
Oh, okay.
What do you expect, Christopher? Any idea about when we might see this third classification, this kind of moderate climate product coming out?
I can't reveal that specifically. I know of 2 companies working on this. Yeah, we'll just sort of say sometime in the next 6 months, maybe.
Oh, okay. Well, that's great. That's
The do-it-yourself one, the roll it up, roll up and put in a vent. That from Efoca, they've been working on it since 2021, and they've had another product in its way. And they say we're almost done with this next tack, which is supposed to be a passive house ready product that goes into the sleeve of a hotel type window, like heat pump, the ones that are below the window, those long ones. So it's be like super well sealed and got an ERV built into it. So they've been loving the heck out of that for years, but they're almost done. And so the roll it up type that's got the cold climate that does, all of that's supposed to start at the end of this year. And I would expect then another year. So 2027 is when I'm hoping that comes out, with or without the grant.
Interesting. Okay. So that's Efoca, and then you said a couple manufacturers. Do you see just a general interest in this product category from manufacturers? Are they waiting to see how it shakes out?
I'll be honest, if you were thinking about importing products and these are manufactured outside the US, there's a lot of uncertainty going on right now on like how big of a factory order do you place? And what's the price point you're going to be able to sell at? So I think that we've experienced a fair bit of nervousness underneath all of this. And it's just the reality of where we are right now.
It's terrible for new product development. I'm trying to work on a 120-volt induction stove with Summit, 3 burners, a smaller oven, but perfect for NYCHA. They put out a competition for that too that I got to help write. So they're doing essentially like we have a factory in Turkey and we have one in the United States. We have one in Thailand. We have like they're having to double up every component. They're trying to find 2 different places because they can't predict who's going to get hammered with a tariff next. It's very labor and time intensive and wasteful and not at all a good market right now to try to bring products in. I mean, like it's just hard to develop things with so much uncertainty around the business
Yeah.
model. It sucks. It's the bad moment for what we're trying to do.
And a lot of these swing and rotary compressors of small size, they're made by that tens of millions outside the US. That's not so much the case here. So if we wanted to even develop that manufacturing capability here, it would take quite a while, many years.
Yeah. You know, like Daikin opened up that 100-acre factory down in Texas. It was a big deal that they did it like only in a year and a half because they did it like tilt up and it's all just one gigantic roof, et cetera. Like, yeah, it takes a long time to build up factories.
Yeah.
Anyway, we understand each other.
All right. No, that's a little bit of a reality check there on the difficulties manufacturers are facing. But this has been great, Brian. Any last thoughts?
Well, we should probably wrap it up. I'm really excited about this category. I think we're going to just see more and more options available as we go. But thank you for Christopher and Sean for joining us today. That was really helpful to have your real world experience in this zone. And thank you all of our audience for tuning in. We'll be sending out presentation with all the notes and links and all that kind of stuff shortly to everyone who registered.
Yeah. Thanks so much, y'all. Good luck with your lecture.
Yeah, thank you very much.
And thanks, Christopher.
Thanks for organizing a great event. Terrific attendance. Good on you. Huge number of people. All right, you guys take care.
All right, bye-bye.
Yeah, take care. Thanks. Bye-bye.